Actually, whatever the requirement which you updated on the same basis, we started the implementation and we completed. This is a data pre-processing. First, I like to show the data set related to your projects. You updated me that IoT 23. So on the same basis, I just downloaded a lightweighted data set. That is, this data set is nearly 8.8 GB files. Okay. I downloaded these files and I am importing these files and I'm creating a CSV file. From that I am implemented your project. So you can see I directly imported the path. So this is the path for each data set. I imported this many data set only we are importing. So once I imported this data set, the data pre-processing, once this is completed, it will stored as IOT 23 combined CSV file. It's going to be stored, it's going to be dumped on this path, okay, which I already executed. So it is already available just in front of you. I am deleting this file and I am saving it. Right now I am going to do a data pre-processing step. So based on it, it's going to be giving the parameters which are all available. So these are all the parameters we are getting. And now you can see here IoT 23 combined dataset has been created. In front of you only I had deleted this, but now it is created. So then here I am applying ML classification algorithm with CNN trained modules, and I am here creating a PKL file, and also I deployed a front end. If I give any inputs based on those values, these are all the parameters I imported, right? And it will detect what type of attack it is also. So right now I'm going to execute. While execution, I will explain you which are all the things I had imported. Sorry, I just executed the same. That's wait. I'm going to execute this train CNN file. So it's showing the dataset name and whatever the parameters we are having. So based on that, it's giving you the plots that overall what will be the attack types here we are using, labeled and count of the attacks which we had imported here on the same basis. So you can see here, once I dumped the data, I'm having this many rows and this many columns. And here I'm pre-processing that because once we created the CSV file, from that we are pre-processing it. So number of duplicate rows which we found, and number of duplication rows after which we removed, okay, and we are showing the data set. And right now we are processing. First I am giving the SVM, okay. For SVM I am getting 0.93% accuracy. For that, this will be the classification report of precision recall, F measure and supports. And then it's identifying how much beginners, all those things. Again I am importing the next step, that is once the SVM is completed, you may see here, first I am doing SVM classifier, and then I am applying here the next Navy Basin. After Navy Basin, I created a clean data set, that is these are all the things, decision tree, and finally I'm using CNN. So Navy Basin, for the Navy Basin I am getting this result. And for decision tree, I'm getting this what the result. Finally, I'm entering into CNN train module. It will take some time. I'm given here totally 10 e-pouches. So while the training, loss will be decreased and accuracy will be gradually increased. For first time of training 1 bar 10, okay, I'm getting accuracy nearly 0.6% and I'm getting loss will be 0.8%. On next epoch, that is 2 bar 10, obviously the loss will be decreased gradually and accuracy will be increased gradually. Wait and see. So now you can see here totally I'm getting here the first three pouches loss will be 0.86, and for the next three pouches it's reduced to 0.85, and I'm getting accuracy will be 0.6078, and gradually it increased to 6097. On the same basis it will increase and it will reach nearly 0.9% of accuracy while I'm getting the e pouches 10 cross 10. So once 10 cross 10 e-pouches is executed, so nearly we are getting 60% of accuracies, and also we applied the precision recall efficiency values we are calculating. So for testing we are getting 6% accuracy. For training we are getting 94% of accuracies. So you can see here for the precision recall F measure classification parts, and we are defining that PKL file. We are creating here the PKL file. Once it is created, it will stored over here. Okay, then I'm going to execute application based on that. So I'm copying the path and we need to open Anaconda command prompt. So first we need to import the path here. I imported in D drive, so I imported the D drive path. So the execution procedure is Python file name dot py. The file name is app.py. Once the execution is completed, it will provide you the localhost running URL. So we have to open this on any browser, not only Chrome. You can open in any browser. HTTP dot. So I'm pasting over those paths. So it will provide you the website. So here once the website is got display, you can able to import all the parameter values and you can detect what type of IoT based attack it is. We can able to detect over here. So based on it, these are all the parameters we are having. Based on the parameters, we are going to give the input values. So based on that, we need to give input values. Once we deposit the input values, based on the input values, it will predict what type of malware it is. So I'm giving the predictor process. Once it is predicted, it will show you what type of malware it is. So if I change some values, it will provide you different outputs. Domain. Yeah, yes, yes. Two. So based on the values, the malware name will be vary. So this is how the project has been implemented. The complete project's execution has been over now.